All right, in this chapter, we're going to look at some probability. And the formula for probability is this: the number of favorable outcomes. In other words, what did they ask for? That goes on top of a fraction. And on bottom of a fraction is the total number of outcomes. In other words, what was possible. So it says if a single coin is tossed, find the probability it'll land heads up. Okay, so when we do our probability on top, think about a single coin. What are your choices? You can either get heads or tails, okay? So the probability it'll land heads up is 1 out of a total of 2 because you had 2 choices, heads and tails. And the probability of getting heads is 1 of those 2. So the probability would be 1/2. They sometimes write it as a decimal. So they may write it as 0.5 or they may write it as 0.50. Either way. Or they may write it as a percent, which means you move the decimal twice to the right and you get 50%. There's 3 ways to do that. Let's look at another example of probability. This one says, Kathy Campbell wants to have exactly $2. Okay, so we're looking for the probability of exactly $2. Assuming that boys and girls are equally likely, find the probability of success. Okay, so if she has 2 kids, well, the first child can be a boy or a girl. Okay, then she's going to have more kids. So the second child can be a boy or a girl. Now what I'm doing is called a tree diagram and it helps you map it out. Okay, here the second child could be a boy or a girl. So let's talk about what happened here. She could have 2 boys. Okay. She could have a boy first, then a girl, if you follow the tree. She could have a girl, then a boy. Or she could have a girl and then another girl. So there's 4 total options. We're going to put 4 on bottom. Okay. There's 4 total options, but how many times was it exactly 2 girls? Only one time. Only one time did we end up with exactly 2 girls. So for part A, the probability is 1/4. Now let's say, what if she had 3 kids? Okay, so the first one could be a boy or a girl. Let's do this one over here. The next child, boy or a girl. Now we need to do a branch for the third child. So the third child up here, boy or girl. This one, boy or girl. Running out of room here. This one could be a boy or a girl. And down here, this one could be a boy or a girl. So now let's follow the tree across and get all of our possibilities. So we could have, if we follow the first branch, we could have 3 boys. No girls. If we follow the next one, it could be boy, boy, girl. So this one would be boy, boy, and then a girl. Let's do the next one, okay? Boy, girl, boy. So boy, girl, boy. Or boy, girl, girl. Then we switch down to the girl. It could be a girl, boy, boy. Or a girl, boy, girl. Or we could have a girl, girl, boy. Or the last one would be all girls. Okay, so let's look at this. We have 1, 2, 3, 4, 5, 6, 7, 8. Our number on bottom is going to be 8 because there are 8 possibles. Now let's count how many give us exactly 2 daughters. Well, there I have all boys, 2 boys, a girl, 2 boys, a girl, 1 boy, 2 girls. So this one right here. 1 girl, 2 boys. There's 2 girls and 1 boy. So right there. There's another 2 girls and 1 boy. Now we need exactly 2 girls, so we don't want 3 girls. So out of those 8 opportunities, 3 of them will give you exactly 2 daughters.